Hello all. In this video, we learn about the elements of microcontroller ecosystem power supply for embedded system. This is a continuation of the previous topic and this comes under embedded system design. Previously, we have learned about the switching regulator 3 where we have used two transistors in order to regulate the input voltage and the output voltage to get a regulated output voltage. Here the switching regulator 4 we are using that is nothing but LM3668. So the input voltage can be given in the range of 2.5 volt to 5.5 volt. Two capacitors we are using, VDD, capacitor C1 and capacitor C2. VDD, V input are there, pins are there. SW1 and SW2 pins are connected by means of inductor of capacity 2.2 μH. Enable pin is there, sync mode we have, FB pins we have ground pins. So in the switching regulator 4, we have two transistors, one is Q1 and another one is Q2. Two diodes are there, two Zener diodes are used in order to regulate or exactly to get the perfect output with efficiency, with accuracy. So diode D1 and D2 are used, Q1 and Q2 are used. Diode D1 and D2 are connected parallelly with the inductor L1. Bulk boost converter or the controller we have, which boosts the input voltage and reduces the noises, reduces the extra environmental noise, environmental disturbances and distortions would be reduced with the help of the bulk boost controller and we get the output. So the next one is switching cell phone charger. So this E of average. So the formula to get the energy is 4 into F into N A B. So here the voltage can be in the range of 100 to 240 volt. We have a capacitor. We have a TNY267 charger. We have diode, normal diodes, Zener diodes are used. We have a transformer. So the transformer is a primary transformer and which is then connected to a cell phone charger. This also is a best example for embedded system design, and inside the charger we will be having this kind of circuit or the design. So that is why when we open the cell phone, we can find some small circuits and PCB boards, right? So that PCB board will be following this kind of circuits. So two diodes are used. One is BA159 and Zener diode one is used. Zener diodes two are used. ZD of one was of 5 volt and another one was of 180 volt. So various power supply topologies can also be adapted in embedded system. Line frequency transformer along with a linear regulator, line frequency transformer along with the switching regulator can be used. Switching power supply can be used. Capacitive attenuator can be used along with the Zener diode. Alkaline boost or bulk can be used. Lithium with boost, lithium with bulk boost, lithium with boost for 5 volt, radio frequency based ultra low power supply, Faraday based power supply can be used, solar plus battery regulator can be used, thermoelectric based topologies can also be used. So modern ICs nowadays design like partition, designed in terms of partitions, speed versus noise margin trade-off, analog subsystems, all the above leads to multiple power supply rails. Linear power supply for embedded processors. So the first rail we have VCC 1, VCC 2, IO2. The rail voltage can be in the range of 1.1 to 3.3. EST input current, input output, uh, uh, current output can be in the range of zero point 0.2 to zero point 0.6. Power output can be in the range of zero point 0.6. So power, we know that power is equal to voltage into current, right? So that is what they have mentioned here. So the converter can be either a linear converter and the efficiency, in order to obtain the efficiency, power out efficiency of a power supply, if we want to determine, then P output divided by P input is the formula. But if we want to determine the efficiency of the voltage, then V output divided by V input is the formula. So converter we have required, they have calculated this. Power optimization. Broadly, three levels of power consumptions are there. One is active power consumption, sleep mode, and power down mode. In active mode, full power and performance will be consumed by the system. But in sleep mode, oscillator will be on, synchronous components will be in off. All the components will not take their power. Asynchronous will be on. Interrupts RTC extra will be on. The system can restart fairly quickly in order to save the power. Power consumption would be in half condition. Half power only will be considered. Power down mode. 1 by thousandth of active power. Power down mode means completely switching off. 1 by thousandth of active power will be consumed. All the components will be switched off completely. They will be in full stage. So power backup resources. We have power backup resources like batteries and supercapacitors. These are the two devices which can be used for saving the power. Battery characteristics. These are the battery characteristics we have. These are the types of batteries: lead ACID, NICD, NIMH, Li icon, Li ion, Li poly. These are the types of batteries which we have. Based on the necessity of the power, we can select the type of batteries in embedded system. See you in the next video. Until then, it's bye from Radhika.